Okay, hello everybody, what's going on? This is Muhammad, welcome to another video. In this video, I'm going to show you how to solve for this geometrical problem here. So we have here a square, LPOQ, and we have a quarter circle, okay? And then we have the two line segments, LM and NM are of equal length. Okay, and the question is asking us to find the angle between the line segments LM and MM, okay? So that's the problem. So if you're interested, pause this video, give this problem a try, and then keep watching this video for a solution. And by the way, this is not an easy problem. So if you're able to solve this problem, then I congratulate you. You're one of the best. Okay, so to solve for this problem, what I'm gonna do here, I have already created another figure. Okay, so we have the square LPOQ, and we have the line segments LM equal to the line segment to the length of the line segment. LM is equal to the line segment to the length of the line segment MN, and we want to find theta, which is the angle between the two line segments. Okay. So I'll present here a very simple way to solve this problem without, okay, so as I said before, this is not an easy problem. So it requires quite some thinking to come up with the right solution. Okay, so I'll start by assuming, okay, that O is the origin, okay, and since, as you guys can notice, okay, theta here does not depend on, is not going to change, okay, whether, regardless of how big the square is. So without loss of generality, I will assume that this square is of length 1. So for that, I will let this point here be 0, 0, which is the origin. And this one here is 1, 0. And the point here is 0 and 1, okay? And the point here is simply 1 and 1. And I will assume that this point here is nothing but A and B, okay? So we have two unknowns here. And also I will let the length ON here, this length here, to be C. So that makes this N equals to C and 0, okay? So apparently here we have A, B, and C. We have three unknowns, and for that we need three equations. I guess this is, okay, the simplest way to solve this problem without making a mess of everything, okay? So the idea is to come up with a system of three equations, okay, enough to solve for A, B, and C. Once we know A, B, and C, we can know everything, actually. So for the angle, we're going to come to that, okay, right after we solve for A, B, and C, okay? So simply what I will do, okay, so I'll leave that to the end, okay, to calculate for the theta. So first of all, our job is to find to solve for A, B, and C. Okay, so the first equation that we can think of is basically that the point M happens to be on the circle. So basically it satisfies its equation, okay? And what is the equation of the circle? It's simply x squared plus y squared equals 1, okay? Because we have assumed, okay, that the length of the square is equal to 1. So that gives us our first equation. So simply a squared plus b squared is equal to 1, and that forms our first equation. Let me deactivate the math thing here. Okay, sorry, again. Yes. So that forms our first equation. We need another equation. We can benefit from the fact that the line segments let me highlight maybe that in this color. Okay, so this length here is equal to this length here. Okay, so basically we can come up with equations, okay, that tells us, okay, that the lengths are equal, and we can benefit okay, from the distance between 2 points. And since, okay, we have a square root, we can get rid of the square root by squaring both sides. So a minus 0, that makes it a squared. So the length between LM is a minus 0, which is a squared, a minus 0 all squared, plus b minus 1 all squared. Okay, so that gives us the length of LM. So a squared plus b minus 1 all squared. So that is the length, the squared length actually, of LM. And then let's find, okay, the length MN, which is simply a minus c all squared plus b minus 0 all squared. So it's going to be b squared plus a minus c all squared. And that forms our second equation. Now, two equations are not enough. We need to come up with a third equation, okay, to solve for A, B, and C because we have three unknowns. So what I'm going to do here, we can benefit from the fact that P, M, and N they happen to be in the same line. So that makes the slope PM is the same as MN. So we're going to benefit from that as well, okay? So the slope of PM is nothing but 1 minus B over 1 minus A. Or what we can do, we can use the slope Pn, which is the same as Mn, okay? So maybe that would make it easier because the slope of Pn is 1 minus 0, which is 1 over 1 minus C. So 1 over 1 minus C. 1 over 1 minus c is equal to the slope of mn, which is b minus 0 over a minus c. So b over a minus c. b over a minus c, and that forms our third equation. Okay? So that's it. Now we have a system of three equations. So what our job, our job now is to solve for these equations. Okay, let me just double check the equations. A squared plus b squared equals 1. Yes. A squared plus b minus 1 all squared. By the way, it doesn't matter, okay, because it's squared. So b minus 1 squared or 1 minus b squared, it doesn't matter because they're all squared. And this is equal to b squared plus a minus c all squared. And then the slopes, okay, 1 over 1 minus c equals b over a minus c. Exactly. So now we have a system of three equations. Now to solve for these, I have already written this in Wolfram Alpha, so I'll benefit from Wolfram Alpha. Let me open it for you here. This is Wolfram Alpha, and I have put the equations here. Okay, I have written the equations in the Wolfram Alpha format. Okay, so the solution is that A is 0.74987667 and B is 0.661588, and these are approximate solutions. And C, of course, we can look for more accuracy, and C is 0.26863. Okay, so that makes A, B, and C approximately equal to A is nothing but 498. I'll just use 4 decimal digits, okay, to make it simple. So 0.6615, and that's B. And C, which is 0.2608. I have just used here 4 decimal digits, okay, of accuracy just to make it simple, okay? But of course, you can go for whatever accuracy you're looking for here. Let me go back to Wolfram Alpha. I can use more digits here, and then you can get better accuracy for these numbers, of course. Yes, there it is. Now we have A, we have a lot, a very good and excellent actually accuracy here. So we're going to use that. Now to solve for theta, what I will do here, I will benefit, okay, from the dot product. Okay, so I'll let ML be the vector A. So let me write that in blue. So this is A. I'll assume that this is the vector A. So A is ML and MN is B. Okay. So simply theta would be the inverse cosine of the dot product of A and B divided by their corresponding lengths. Okay, so theta is going to be equal to cosine inverse of A dot B divided by AB, where A is the length of the vector A and B is the length of the vector B. Okay, so for that we need to come up with, to define what A is. A is simply, I'll use the brackets, okay, to represent the vector. A is simply ML. So it's going to be what? It's going to be 0 minus A. So minus A, 1 minus B. Minus A, 1 minus B. That's the vector A. Of course, we can use IJ, but this is simpler. And B is simply MN. So it's going to be C minus A minus B. C minus A minus B. C minus A, I'm sorry, C minus A and then 0 minus B, so which is minus B. Okay? So that makes theta. Now we can, of course, come up with A dot B. A would be minus A multiplied by C minus A plus 1 minus B multiplied by negative B. Okay, so that's the dot product. And AB is going to be equal to A squared plus 1 minus B all squared. And this is going to be multiplied by the square of the second one, which is what? Which is C minus A all squared plus minus B all squared, which is what? Simply B squared. And I have to use what? The square root of that. Okay? So that's the length of A multiplied by the length of B. Remember that the length of A is the square root of A squared plus 1 minus B all squared. And the length of B is the square root of C minus A all squared plus B squared. And then I merged, okay, the square root and under one variable as a single square root. And this is going to be the multiplication of the squared lengths of the two vectors. That's it. Now I'm going to take the dot product in AB, plug that in the formula, and then come back to Wolfram alpha here. And this is exactly what I did here. Okay, if you can look at the last part here, which is theta cosine inverse of the numerator is nothing but the dot product of the two vectors A and B, and the denominator is the square root of the squared lengths of A and B, and then I have multiplied at the end by 180 divided by pi so that I get theta in degrees, not in radians, and that's it. If you look at theta is going to be 77.81999 degrees, okay, and that's the exact answer if you're looking for that. Okay, so let me write that down, and then I'll provide a way to verify if this is true or not. Okay, so theta is simply approximately equal to 77.81998 and then 6323623. Of course, we can write better accuracy by providing more decimal digits to the right of the decimal point, but this is enough. Okay, I'll highlight this, okay, because this is okay, basically the final answer. Now, to verify that this is true, what I'm gonna do here, I will use GeoGebra here, okay, and then I will sketch the square. So I'll start by sketching the points, or okay, 0, 0, that's the origin, okay, and then 1 and 0, and then 0 and 1, and the last point is simply 1 and 1. Okay, I'll make that bigger. Okay, I have to connect the points, okay, A, B, B, C, C, D, whatever, okay, and then I'm sorry, okay, let me get rid of the let me keep the letters. Okay, so and then I will sketch, of course, a quarter circle, and I can use this here. Okay, and then I have to define the point, let me go back here, the point N, which is C. So for that I need C. Okay, and C is nothing but, we can go, of course, to Wolfram alpha, okay, and get the exact value for C, which is 0.2608. Okay, so let me put that on the sketch here. Okay, so I'm sorry, So C is nothing but 0.26, C 0.26, 086, 086. We have to be very accurate here. 086, 3448, 3448, and then 226, 226, and then 439, 439, and 647, 647, and 68. That's it. And then I have to put, of course, 0 here, so that would give the exact point C on the sketch. Then all I need to do is to connect these two points here, okay, and then define that point here, and then sketch, okay, the 2 line segments, which is, yes, okay, let me make this in red. Okay, so, and this line segment here, of course, it has to be 2 line segments actually, so that we can, okay, and then what I will do, I will just let this be highlighted in red. Now the 2 line segments are equal. Now all I need to do is to calculate or to measure, okay, the angle between E, F, and C, and maybe get a better accuracy. The maximum accuracy is 15 significant figures, and that's exactly the number that we got, okay? 77.819986. Let's go back to Wolfram Alpha. It's exactly the same, okay? 81998623, and from GeoGebra we get exactly the same number. Okay, so that concludes, okay, my solution. If you guys like this video, don't forget to hit like, share this video, and subscribe to the channel. If this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.